So, currently our farm is producing approximately 20,000 liters per day, with some fluctuations, and around 500 lactating cows.
This current diet is a single diet. We operate with a single feeding strategy. So, we currently implement a nutritional management operation with 3 feedings per day. Our herd's average dry matter intake today is 23.7. That is our current intake. Regarding fat content, our annual average for the 12-month period closing 2024 to 2025 was 3.9% fat and 3.42% protein. We slightly reduced the starch content to try to offer a bit more comfort to the animals and avoid negatively affecting performance. We felt the impact, although less intensely.
On our best days, we harvested around 800 tons per day within 12 hours. That equates to approximately 66 tons per hour of material effectively reaching the silo on average. And we had 65 tons of equipment compacting the silo. So, just with that, we already achieved 100% compaction. The material is then pressed with approximately 3 tons of pressure and passes through 2 such systems. 2 pairs of rollers carry out the pressing process.
So, this is the material that comes out with 32% dry matter. It drops here, we spread it. Currently, our standard usage is 15 tons. 15 tons of material per bedding replacement.
In terms of energy, we estimate savings of around $100,000 in energy costs over a 6-month operational period.
We receive the first animals here. We work with groups of 20. We can observe that the stocking rate in our heifer rearing unit is high. We are operating here, whether we like it or not, with 20% above our pen capacity.
Our own land area here is relatively small, only 50 hectares of arable land. Yet we are able to deliver whole milk, homogenized and pasteurized. It is a simple process that offers a high level of consumption safety. No preservatives, extremely fresh.
Jesse sent a message saying that he won't be making videos anymore because you haven't subscribed to the Santa Fe channel. So subscribe now, and he will continue recording on farms around the world.
Welcome to our channel. Today I'm here at Querência do Guaçu farm in São Paulo, and we're going to show you a cross ventilation system. But here there are some unique features. They're implementing different approaches, and I believe this will be very useful to each of you watching this video. I'm here today with Marcio and Renato. AO, you will see many tips regarding agriculture and livestock.
Speaking a bit about our history, this is a project that began over 40 years ago in the 1980s with my grandfather and my father. Our family has a tradition in both dairy and beef cattle production. Our grandfather bought this property in the year 1960 or 1970. Initially, this was a leisure area for him. He had a great passion for animals. My father graduated in the 1980s, and shortly after college, he returned here as well. Previously, we had swine and dairy cattle. Not long after, my father prioritized dairy cows. Starting with a herd of 15 cows, we gradually built up what we have today. Those 15 animals were acquired in the 1980s, and no further purchases were made. So, all of our genetics have been developed right here on the farm. Today, we have nearly 1,200 animals in the total herd. Now, with my brother and me, both of us returned right after graduation. We are envisioning a larger project. We dream of reaching 2,000 lactating cows. That's the milking capacity we're planning to acquire. Whether we'll get there or not, time will tell. It's not a fast process. We've always grown in a very organic and natural way, all with our own resources, facing challenges head-on since the beginning. So, that is our dream. We hope to achieve it. We did not expect to reach 500 lactating cows until just a few years ago. So, this is all part of an ongoing process. It may take at least 10 to 15 more years. However, we are structuring and organizing ourselves to make it happen. It is a dream that began 40 years ago with our parents. At that time, it was their dream alone. But today, it belongs to all of us, the children, the grandchildren, and the 4th generation that is on its way. It also belongs to our team members, who make it possible to achieve the results and the efficiencies we see in various sectors of production. Although the operation has taken on a slightly more business-oriented scale, it remains a family-run business. My brother Rafael and I are in charge of operations, and our parents are involved in financial management and provide strategic advice. As for the staff, many of them, especially those working in the dairy sector, live on the farm. A significant number have either familial or emotional ties to us. So, all of us here form one big family with a shared purpose: to provide high-quality food to the population, always acting with respect, animal welfare, accountability, and with the greatest environmental and social sustainability possible. It is a mission that we believe God has entrusted to us, to feed the people. And I believe we are able to carry out this mission with a certain degree of skill. It is not easy. We go through difficult times, moments of concern, but thanks to God, the business continues to grow steadily. We have a vision for expansion, and we are excited about that. Speaking a bit about animal welfare, we are currently inside the cross-ventilation barn, and our milking parlor is also located within the cross structure. This is the ideal environment for the cows, where we are able to control the main variables that directly impact their comfort: temperature, humidity, wind speed, the post-milking period, and the cooling loops. Everything is monitored. Here, we are able to manage all variables to provide the highest possible level of well-being for the animals. And the outcome is exactly what you see here. We have a calm herd, animals that like being around people, that enjoy their routine, the work they perform, and the purpose they fulfill. Having them close to us gives us great satisfaction and affirms that the welfare we provide is recognized. And they return that care in the form of milk.
Well, here we are in our management area. This is the exit from the milking parlor. The animals come out from milking here. Marcos is our team member responsible for animal health and reproduction. He carries out all this work. Vinicius currently assists Marcos and is a veterinary medicine student. He is actually Marcos's son, a veterinary student, and also serves as our milking supervisor. So, there is a strong integration of families. We can see sons following in the footsteps of their fathers. We provide opportunities, and they continue working across different areas. These animals here are already being prepared and scheduled for embryo transfer. In fact, for oocyte collection, which is scheduled for next week. Currently, the farm does not separate groups by production level. We are divided into 5 groups, primarily based on animal size. Grouping is mostly by body size, although there is some pre-selection. At this point, we do not have a specific transition group. This is especially true for the postpartum stage. The prepartum animals are housed right here in front. We do have a postpartum group, though there are also some other animals in higher sections. Our prepartum animals today are housed in a freestall system. Once calving begins, the cow is transferred to the maternity pen. Afterward, the cows are directed to a holding group so they can be milked for colostrum, and the heifer calves are taken to a waiting pen where they immediately receive their first treatments, including navel disinfection and colostrum feeding. Currently, we are operating with an average of 476 lactating animals. Our production average is 39.3 liters. We have a suboptimal average days in milk, which has slightly penalized our overall average. As of now, we are producing 39.3 liters with an average DIM of 215. Feed efficiency is at 1.66. As we approach the winter period, around August or September, we reach up to 1.72 in feed efficiency. The current average dry matter intake of the herd is 23.7. That is our benchmark consumption. This group located at the front is a specific transition group, positioned ahead of the prepartum animals. Its placement allows for easier access, loading, and transport of animals to that area. They are mobilized from here to our handling center. The positioning enables us to move them efficiently for any procedures required during the postpartum phase. Their assessment is conducted further along in the operational line. This layout allows everyone to keep a close watch on these animals so that any necessary intervention can be carried out in a timely manner. Regarding our groups, as I mentioned, we do not manage them based on production. We work with a single diet. Our grouping is more focused on somatic cell count. We have one group based on SCC and others based on cow size. Primiparous cows are kept together. and second lactation cows are in separate groups. This setup greatly optimizes, given that we are consistently operating with high stocking density, the ambient conditions and behavioral comfort of the cows. It helps reduce disturbances and prevents dry matter intake from being negatively affected, ultimately improving feed efficiency. With this single diet, we also operate with a single feeding time. Our nutritional management system is based on 3 daily feed deliveries. A single mixer wagon typically serves 2 groups. The only metric we monitor daily is dry matter intake. We set feed refusal at a maximum of 2 to 3%. Every morning, this is measured. Unlike many farms where feeding occurs in the morning, here, lactation feeding begins at noon. So, at midday, this first group is sent to milking, 10 minutes before 12 o'clock. We then proceed to remove all excess feed left for 24 hours. This leftover material is pushed aside and later collected to be used for feeding our Angus cattle, which are finished here using feed leftovers. Once that group is cleared, we provide the fresh ration. The groups are generally numbered based on their milking order. So, this is Group 1, the first group to enter the milking parlor. This group mostly consists of second lactation cows. To complete the group, we sometimes include smaller framed multiparous cows. Here, basically, you can observe, by looking at the facilities, that some curtains and enclosures, especially the deflectors, are noticeably cleaner. On the opposite side, you will see that we are undergoing structural expansion or making some necessary adjustments. We had structural issues in the older parts of the barn. Last year, we struggled somewhat with the heat, even within an enclosed environment, but since September, with the expansion, we have implemented several changes. We had to extend the facilities. Previously, the milking parlor was located outside the cross. It was not within the negative pressure structure. As a result, when we opened the structure and extended it slightly, we experienced a loss in operational efficiency. This impacted the airflow and heat removal within the barn. Some groups were negatively affected. We experienced a decline in reproductive performance, and we are still feeling the effects of production losses. In the past 3 years, we had never seen average production drop below 40 liters during this same period. But this year, we experienced that. It was due to the expansion, an issue we had anticipated, but one that we had to face eventually. From a nutritional standpoint, we tried to hold the line a bit more. We loosened the diet structure, increasing fiber levels, particularly forage and DF. We also focused a bit more on the lipid structure, specifically the ether extract of the diet. We reduced starch content slightly to try to improve cow comfort without severely impacting performance. The effects were felt to a lesser degree, but they were still noticeable. We experienced a rapid loss. We dropped 2,000 liters of milk in a single blow right after those changes. We lost 3 liters in average yield, but then started recovering. Even today, we are still down by 1 liter from our historical average. With winter approaching and the construction projects nearing completion, feed efficiency is returning. We reached a feed efficiency of 1.53, and now it is rising again. In recent days, we've seen it climb to 1.74. Since we always aim for operational simplicity, we avoid major changes to our daily routines, making it easier for the team to follow protocols effectively. We have always opted for a single diet, and also to avoid frequent reshuffling of animal groups. Even when cows move between groups, it does not cause nutritional stress. Additionally, we face some limitations in terms of ingredient availability. Today, our diet is composed of 50% forage. 50% of the dry matter is forage, and 100% of that forage is corn silage. The farm always prefers to work with resources produced internally. This is both for cost efficiency and to maintain control over all operational processes. We know that the silage we produce here is our responsibility, and we avoid outsourcing. For example, buying hay, long fiber, or pre-dried forage. Besides being more expensive, such materials are often of unknown quality. In fact, 5 years ago, We used to work with externally sourced materials that were not of good quality, and this resulted in production variability. Here, we are able to maintain a more stable ration throughout the year, so our diet is essentially based on corn silage. We also use ground corn, cornmeal, cottonseed, soybean hulls, soybean meal, and our buffered mineral premixes. Since we operate with a single diet, all animal groups receive the same formulation, including methionine supplementation for all groups. Because we do not have a designated immediate postpartum group, we chose to include methionine across the board, focusing particularly on milk solids. We have been implementing this strategy for 1.5 years. Our annual average fat content, closing the 2024 to 2025 period, was 3.9% fat and 3.42% protein. Our somatic cell count last year closed at 280, and this past month it registered at 313. There are some challenges, particularly our increasing DIM, which has resulted in some efficiency loss. Since we do not have another source of long fiber, we always work backwards. We start with the silage and monitor everything to meet the goals we've set for our diet. So, we monitor it closely because we already know the nutritional profile we want to achieve based on the NDF and starch levels in our silage. Currently, the silage has 35% starch and 39.7% NDF. We aim for digestibility as well, and we control that using the Penn State particle separator. Right now, we work with a 14% screen size on the mixer to optimize intake. With a slightly bulkier diet, we can meet our fiber target. This reflects in our fat profile and also in animal health. Based on collar data and health metrics, we have an average rumination rate of around 560 minutes per day. To maintain this, and considering that we operate on leased land, we try not to change our diet profiles too drastically. That's why we conduct weekly monitoring. Every Thursday, our feeding and animal welfare supervisor is responsible for analyzing dry matter content of all ingredients, the total diet, and especially corn silage. He also performs Penn State separation, and we adjust the ration accordingly as needed. As you will see when we visit our silage panel, we use wide silage bunkers. Since silage is our only source of fiber, accounting for 50% of the diet, we cannot afford mistakes in the fermentation process. We aim for a stable and cool material because the fresher the diet, the better the intake. Given that we use a single feeding schedule, this feed stays exposed for 24 hours, so yeast control is critical to ensure consistent dry matter intake. Sometimes, we work right at the fiber threshold to maintain rumen health without compromising compaction. We have a team responsible for both bedding and feed management. They not only push feed forward, but also pull it away from the walls, preventing excessive compaction. If the feed compacts too much, it may over-ferment and heat up, making it harder for cows to consume. So, the team pushes feed away from the walls, ensuring it is well distributed. This feed pushing and wall clearance is done 6 times per day. It's the same team responsible for moving cows to the milking parlor. The rest of the team handles bedding maintenance, including cleaning and disinfection. 2 years ago, the farm decided to stop using pine shavings for bedding. We had always faced difficulties with this material, especially with dry matter and cleanliness. It often arrived highly contaminated, making it hard to manage with lime. Lime in contact with damp pine shavings causes the bedding to harden, which can result in hock injuries and discomfort for the cows. So, 2 years ago, the farm made the decision to switch. It was an expensive resource and not providing good results. Instead, we invested in a manure separator and began testing the dry matter of the separated material. I'll show you that stage later on. Today, our bedding comes from separated cow manure. After going through the separator, we treat the material and incubate it for 4 days before applying it. It is a very light and tender fiber, which dries quickly. The material leaves our separator with 32% dry matter, and, after all the processing steps we apply using quicklime, it reaches 38% dry matter. It results in clean, sterilized bedding that reaches temperatures of 80 degrees Celsius during treatment and becomes an inert material ready for reuse. This material exits the system and returns to be used for cow comfort. That is always our choice. Soft bedding that does not injure the cows and encourages them to lie down. That is what we aim for here, particularly regarding mammary gland health. We notice this in our daily evaluations. For instance, when animals come back from the feed bunk, many lie down right away, indicating that they are achieving the expected level of comfort. This translates directly into greater productivity and efficiency for the animals. We truly believe that animal welfare is fundamental to achieving results. Unlike sand, which is inert and more difficult to manage, we work with living or biological bedding. It requires more stringent control. Since our bedding is replenished more frequently, we maintain a slightly lower bedding depth. Replenishment is done twice per week. Controlling dry matter is essential. If we fail to hit that 38% mark, or if the material enters the barn without sufficient incubation time, or without proper reaction with the lime, we can have mastitis outbreaks in the milking parlor. So, when working with living bedding, extreme care must be taken. We need to monitor the dry matter entering the system, ensure that the material has truly undergone deactivation with lime, and that the lime has been thoroughly mixed. Process control is crucial. If everything is done correctly, we will not have problems. But the fact remains, any mistake in this process can be costly.
It's also important to point out that the organic bedding we use today is derived from treated manure, collected right here on the farm. Adjacent to us is a concrete alley where manure naturally accumulates when voided by the cows. That material is captured, treated, and reused as bedding. All of our pipelines and equipment are designed to handle manure. Before switching to this organic bedding system, we used sawdust. However, we faced several challenges with it. Larger pieces of wood or branches were often mixed in, which caused damage to the pumping system and clogging in the separator, precisely because it was a material sourced externally. We have never used sand bedding, but we know producers who do. It's also an external material and requires a more robust infrastructure. We've seen producers needing sand recovery yards and experiencing increased wear on pumps. With this current system, we were able to bring comfort and health to the cows, while also reducing costs. The material is sourced from within the farm, so there are no logistics involved. We found that it fits our system very well. It's not easy. This is still a developing practice in Brazil. Not every farm that has tried it has succeeded or even intends to try it. But we believe it will work. This is the result of extensive work and research over time, always monitoring and seeking solutions to make it work. There is no single correct model. Each case requires its own approach. For us, this is an economical and efficient system that fulfills the ultimate goal, delivering quality to the cows. This group is currently under renovation due to floor seepage issues. We decided to remove all the bedding, increase the bedding height, and later refill it with treated organic matter so the cows can return. Here you can clearly see the natural ground level without bedding, nearly at the same height as the concrete floor. This space will be filled with treated cow manure. The barn measures approximately 120 by 120 meters. However, part of that area is allocated to the milking parlor and handling area. The largest groups are housed in 120-meter-long corridors, and the tunnel is also 120 meters long. Our milking parlor is currently housed inside the cross. We also observe the spacing between stalls. Currently, we use a stall width of 1.3 meters and a length of 1.9 meters.
We've already discussed the animals, nutrition, how this milk is produced, and the comfort provided to the herd. Now we've arrived at the milking parlor, where we verify whether all upstream processes are truly aligned. Here, just as importantly, we take all necessary steps to ensure proper extraction, maximize animal comfort, stimulate milk letdown, and achieve high flow rates. We recently opted to use brushes during the pre-milking routine for a period of 3 months, temporarily abandoning cloths, aiming to increase the number of cows milked per hour. Despite some initial adaptation challenges and team training issues, we have now returned to our ideal flow metrics: 0 to 15 seconds, 15 to 30, and 30 to 60 seconds. We are recovering our performance. With the brush system, we managed to increase throughput by about 15 cows per hour. The team is now fully adapted. Just yesterday, we had a refresher training focused on fine-tuning pre-dipping and cow stimulation protocols. When it comes to animal health, welfare, and milking management, we monitor everything through our dashboard. Most treatments involve postpartum cows, those transitioning out of the colostrum phase and into regular milk production. We have one cow currently under treatment due to a displacement issue diagnosed 3 days ago. Our clinical mastitis rate is very low. In fact, today, we have no cows under treatment. The farm operates with 3 milking shifts. Due to optimized throughput and the increasing number of cows per hour, as well as the team's efficiency, we now complete each shift in 5 hours. As Renato mentioned, we still have room for growth within the current system without modifying our existing infrastructure. We work with 3 milking sessions and 4 teams, 3 active and 1 resting. This is slightly different from the traditional rotation used on most farms. Our system works on a rotating schedule. Every 4th shift, the team rests. For example, those who work the morning shift rest and then return to work the afternoon shift. After another 4 shifts, they move to the night shift. Once they complete 4 night shifts, they receive 2 days off. We adopted this model to improve the comfort and well-being of our milkers so that when they are working, they are focused and rested, minimizing stress and fatigue. This positively impacts mammary gland health.
Currently, our farm is producing approximately 20,000 liters of milk per day, with some fluctuations, and we have around 500 cows in lactation. We have nearly reached the capacity of our milking system. A double 8 milking parlor is currently operating for 5 hours per milking session, across 3 sessions per day. Therefore, we are now considering our next step, which involves expanding primarily the milking facility. We are already designing and planning what will likely be a 36 milking parlor, with the capacity to milk up to 2,000 cows per day. This expansion is aligned with several other developments already underway. For example, this new shed for heifer rearing, measuring 20 by 130 meters, is nearing completion of its roofing phase, and soon we will proceed with concrete flooring. This entire area on this side is dedicated to the feed center. Our current feed mill is already somewhat outdated and operating near its limit. There is a snap lage silo here, and another one adjacent to it. The new feed center will encompass this entire space, including both silos, which will allow us to stock additional forages, cottonseed, citrus pulp, or any other feed ingredient we might choose to include in the diet throughout the year, aiming to maintain larger inventories. Here we will construct 4 bays, with a high ceiling to facilitate unloading by delivery trucks. Over on the other side will be our silage trench silos, a total of 5 silos, each approximately 65 meters long. We have 4 silos that are 16 meters wide and 1 that is 8 meters wide. We managed to organize the feeding logistics very efficiently. The feed mill here, the supplemental ingredients here, and the forage over there. This has greatly improved the efficiency of the feeder's work. All flooring is concrete. Previously, the feeding wagon had to pass through muddy areas, which led to mud being carried into the feed bunk. But that problem has been resolved. All of our silos are masonry built, both in the walls and floors, which significantly reduces any potential sources of contamination that could compromise feed quality. We are now at the panel of silo number 3. This corn silage was harvested in January. One of the most important aspects we prioritized this year, more than in previous years, was compaction. This silo is extremely well compacted, to the point that there is considerable resistance in removing the silage. In past years, we focused on producing long fiber, adjusting the chopper to cut at 18 millimeters. For this silo, we tested a shorter cut at 14 millimeters, and we applied significant weight during compaction. Since the silo is 16 meters wide, it's difficult to use many machines simultaneously, but we managed to operate 4 machines, totaling 65 metric tons of equipment used for compaction. On our best days during the harvest, we were bringing in around 800 metric tons of silage per day over 12 hours, which equals roughly 66 metric tons per hour delivered to the silo. With 65 tons of compaction equipment, we achieved 100% compaction rate. But instead of limiting compaction to 12 hours, we extended it to 15 hours, surpassing even the ideal ratio. The outcome is excellent: a stable, cold, and well-fermented silo sealed around 4 or 5 months ago. A density analysis was performed and it measured approximately 870 kilograms per cubic meter, which is considered optimal. Moreover, our removal team is well-trained and instructed to extract the panel uniformly. We recently developed an in-house fork attachment to aid in silage removal, particularly in highly compacted silos like this one. If we were using only a standard bucket loader, the machine would be overstressed or would remove the panel unevenly. This tool has proven very helpful in maintaining our standard of silage removal. Initially, our operation and herd were entirely pasture-based. Starting around 2010 to 2011, we began housing the herd, using a freestall barn with mattress bedding and an open structure. At that time, compost barns were starting to gain traction. We eventually decided to transition all barns to the compost barn system, dismantling the previous facilities, removing the mattresses, and adapting to compost bedding. This shed was constructed in modules, initially based on the idea that compost barns were more economical to build. For our development stage, it was a suitable fit. The barn was built with a concrete feed alley, but was open-sided, which led to high costs with fans. We had already planned to implement a cross-ventilation system. From the start, the compost barn was designed with future adaptation to freestall in mind. As our herd size expanded rapidly, one effective alternative was to convert the compost barn into a freestall barn. The transition from compost barn to freestall occurred progressively. One of the biggest challenges we had with compost bedding was managing the manure-based bedding material. Our region is high altitude and highly humid, making it very difficult to dry the compost bed. Our manure removal logistics were insufficient and relied heavily on agricultural workers, which was not well integrated into the dairy routine. As we began converting to the freestall system, it became much easier to incorporate routine maintenance and bedding replacement, which proved very effective for us. At the time we began the compost barn, sawdust was extremely cheap, around $1.6 per cubic meter, nearly free. That cost was essentially just the transportation. There was ample availability of sawdust in our region. Over time, sawdust began to increase in value, especially due to demand for industrial boilers. And today, while I'm not certain of the exact price, I believe it is around $12 per cubic meter. Even after migrating to the freestall system, we continued using sawdust for cow bedding. However, we started evaluating alternatives and decided to test the use of treated manure from the cows themselves as bedding material. We analyzed the microorganisms found in both sawdust and treated manure, and discovered that the harmful bacteria were actually more prevalent in the sawdust. We also analyzed the dry matter content of the sawdust we received, which was around 50% dry matter, not far from what we currently obtain with manure-based bedding. Back when we were using sawdust in the freestall system, our annual cost for that material ranged between $60,000 to $100,000. Thus, we opted to invest in a solid separator, capable of extracting as much moisture as possible from the manure. It took us some time to fine-tune the process. In recent months, we have finally succeeded in optimizing it. We performed several trials using sanitizers, inoculant bacteria, and different treatments for the solid fraction. What has yielded the best results is treating the manure with hydrated lime at a 2% concentration. We have observed excellent results in terms of milk quality and a significant reduction in costs. The funds we previously spent on sawdust were reinvested in a higher performance solid separator, which paid for itself quickly and resolved not only the issue of bedding costs, but also a manure disposal problem we had. Although it could have been used in the fields, it proved more viable to reuse this material as bedding for the cows. Today, This entire barn measures 120 meters long by nearly 120 meters wide, equipped with a cross-ventilation system. The exhaust fans are located here, and the airflow follows this direction. These are the feed alleys and the corridors leading to the free stalls, where the bedding areas are located. Recently, we installed an automated scraper system, which scrapes the alleys and directs the manure to a collection channel. Currently, all manure from the adult herd and most of the young stock is directed to the solid separator. Only a small portion of the younger animals remains in the compost barn system, which we still find suitable for them. In this barn, treated manure is also reused as bedding. Today, we estimate that approximately 90% of our manure is channeled into the system, while 10% remains in the compost barn setup. All this manure is channeled through a gutter system that includes a recirculation mechanism for washing. It flows into a holding basin, where it is homogenized and pumped to a static screen separator, which performs pre-filtration. Subsequently, the material goes through a double roller press, composed of one rubber roller and one perforated stainless steel roller, exerting around 3 metric tons of pressure. The material then passes through 2 of these press systems, resulting in a very dry solid fraction, which is either sent to the composting yard or to the lime treatment area. Like many farms, we have long struggled with manure management, particularly as the scale of production increases, leading to larger and more complex volumes of waste. This challenge involved my father, brother, and myself, and over the past years, we've focused intensively on solving this issue. Today, manure management has become an enterprise in itself. From the moment it enters the tank, it is treated as a separate operational system. This equipment separates the solid and liquid fractions of manure. The solid fraction is used for freestall bedding, compost barn bedding, and the surplus, around 30%, is composted and later reused in crop fertilization. The liquid fraction is sent to the biodigester, where biogas is extracted, generating electricity, and the digestate is used for fertilization. Today, cow manure is transformed into 4 distinct products: bedding, organic fertilizer, biogas, and biofertilizer. Currently, our monthly production is around 600 metric tons of milk. If we compare that volume, it is equivalent to receiving 30 centavos more per liter of milk. This illustrates how critical it is to focus on cost efficiency and internal management, rather than relying solely on market prices, whether from the spot market, cooperative, or suppliers. Sometimes we negotiate over 5 or 10 centavos per liter, when we could achieve significant cost savings within the farm itself, independent of currency fluctuations or foreign domestic markets. Having tight cost control within dairy operations is essential. In this regard, manure has transformed from a liability into 4 revenue-generating products. Many of these revenue streams do not involve direct cash flow, but rather represent cost savings in the activity. Therefore, this project is not only financially sustainable, but also environmentally sustainable, involving nutrient recycling, waste reuse, and reduced logistics needs for external inputs. A highly valuable yet often underutilized resource in most dairy farms.
Once the material exits the solid separator, it is deposited here. This is the raw solid fraction that will undergo treatment. It arrives with 32% dry matter and is spread over the yard. Our current standard application is 15 metric tons per bedding replacement, conducted twice a week, on Mondays and Thursdays, for the cows housed in the cross-ventilated free stall. Here, we spread the material and mix it with quicklime, homogenizing it. We turn the material daily, which raises the temperature to 79 degrees Celsius, promoting drying and sterilization. Once treated, it returns to the system with 38% dry matter, fully sanitized. It is reintroduced to the bedding alleys, eventually pushed into the collection gutter, then returns to the solid separation cycle. This recycled fiber is very light, soft, and dries quickly. In terms of drying efficiency and contamination control, it has outperformed the pine sawdust we previously used. This process ensures good homogenization, sanitization, and avoids teat and irritation or utter dryness, thus maintaining mammary health. We have achieved optimal results with just 2% lime addition, given the volumes we handle today. This is the prepared bedding material. It is hot, and if pushed, it emits steam. You'll notice some grayish ash, indicating a highly inert material. This bedding is ready to be applied. We always operate with 3 piles, maintaining a reserve stock in case of unexpected losses or emergencies. This strategy ensures we always have enough bedding supply. This approach has proven very effective, especially in controlling somatic cell counts and mastitis. At present, our milking system reports 0 mastitis treatments in the herd.
We are now in the biodigester area. We operate 2 biodigesters, connected in series. Part of the biogas is captured in the first unit, and the remainder in the second unit, allowing for sufficient retention time to maximize gas extraction. After the manure passes through the biodigesters, the digestate is stored in a holding pond for later fertilization use. This process is particularly valuable in our silage areas, where nutrient removal is intense. When we apply synthetic fertilizers, we rely on external inputs, but through organic fertilization or slurry irrigation, we maintain nutrients within the farm's nutrient cycle. This has allowed us to reduce fertilizer purchases by 20 to 30%. The digestate is rich in nitrogen, with concentrations slightly above 1%, which may seem low, but when applied at 10 to 20 millimeters per square meter, it becomes highly significant. Our manure system provides 2 revenue streams: biogas, which supplies 80% of the farm's energy demand, and digestate, which reduces fertilizer needs by about 20% in the treated areas. We have been researching biodigesters for a long time. There has been significant innovation in recent years. I began investigating this in 2018, when I returned to the farm, but the market was still not fully mature. In the meantime, we invested in solar power, which now supplies 40% of our energy demand. By the end of last year, we finally gathered the technical information and found a reliable company to support the project, and we decided to add biogas energy production. Now, biogas covers 80% of our energy needs, leaving a 20% surplus, which we convert into credit on our energy bill. Looking back, I'm glad we waited. Many earlier adopters faced challenges. Today, the mixing systems, recirculation, retention times, and membrane covers are all well developed, and in practice, they have proven to be effective and reliable. The biodigesters have been in operation for approximately 6 months, and during this period, we have produced around 600,000 kilowatt hours through 2 biogas-powered generators. These generators operate off-grid, not connected to the utility grid, and adjust output based on demand. In our region, the average cost of electricity is about 2 cents per kilowatt hour, so we estimate that this system has already generated approximately $100,000 in energy savings within 6 months of operation. The biodigesters are slightly oversized, with a retention time longer than necessary. This was intentional, as we are planning for future herd expansion and increased milk production. The current system is dimensioned to serve around 800 to 900 lactating cows. A key aspect for the optimal performance of a biodigester is maintaining a constant and stable inflow of material. Since it is an anaerobic biological process driven by bacteria, it is essential to avoid introducing chemical contaminants into the system, such as milking parlor wash water, which must be redirected to prevent interference with bacterial activity. The manure enters the biodigester via a pipeline, which splits into a wide junction to distribute the flow. The ideal retention time is approximately 30 days, but currently we are operating at 50 days, which is why we describe the system as oversized. The biodigester itself measures 60 meters in length, 20 meters in width, and 5 meters in depth. It is equipped with 2 agitators and a recirculation pump. The recirculation pump is crucial to avoid sludge accumulation at the bottom, thereby reducing maintenance needs and enhancing gas production through continuous agitation. At the outlet end, the recirculation pump redirects inoculated material, rich in bacterial colony-forming units, back to the inlet, facilitating faster and more efficient biogas generation from the incoming material. Currently, our biogas composition is excellent, averaging 65% methane and 10 parts per million of hydrogen sulfide, a very low level that prolongs the lifespan of the generators. In general, it's a simple and reliable system to operate. It is a low-maintenance setup that operates autonomously. We check it periodically, but overall, it is integrated very well with our operation, especially since we have a high on-farm energy demand. We use cross-ventilation, electric-powered pumps, and we also have an on-site feed mill. Our current monthly electricity consumption is approximately 100,000 kilowatt hours. Given this demand, having our own energy source has provided a highly effective cost reduction strategy. As previously mentioned, the market cost of electricity is about 80 to 82 cents per kilowatt hour. With the biogas system in place, we estimate that our current energy cost is under 10 cents per kilowatt hour, already factoring in generator maintenance, investment payback, and solar panels upkeep. By reducing energy costs by a factor of 8 to 10, we've addressed one of the most significant cost components of confined dairy production. This system fits our model extremely well, and we intend to continue expanding our investment in self-sustaining energy generation. As I mentioned, this biodigester system is oversized and designed to accommodate up to 800 to 900 cows. Considering all biodigester-related costs, we estimate the operating cost at approximately 1.5 to 1.6 cents per liter of milk. However, we treat this as a core dairy operation cost. To us, the biodigester is a tool that helps produce higher quality digestate, thus enabling better organic fertilization. We attribute the energy generation cost only to the biogas generators, which amounted to $500,000. So in budgeting, we separate the biodigester as part of the manure management system and the generators as part of the energy system. In total, including earthworks, labor, and geomembranes, the combined project cost was around $362,000. Another interesting observation: our biogas and energy production is directly related to milk production. It's early to make definitive conclusions, but in December through February, we noticed that during periods of heat stress, when milk production fell from 21,000 to 17,500 liters per day, biogas output also decreased significantly. We initially thought there was an issue with the biodigester, but ultimately we linked the drop to decreased manure output, stemming from lower dry matter intake and milk production due to heat stress. When cows experience heat stress, they reduce dry matter intake, which leads to lower manure production, lower milk yield, and consequently, less substrate for bacterial fermentation in the biodigester. This reduction in available organic material explains the decrease in biogas output. I track this in a spreadsheet, calculating gas production per animal unit, converting heifers, calves, and cows into a standardized animal unit metric. I'm trying to establish correlations between animal units, milk yield, and biogas production. As milk production climbs back to around 20,000 liters per day, biogas generation is also increasing. Here we have Bio 1, and adjacent to it, the transition chambers. There's a 50 centimeter elevation difference between Bio 1 and Bio 2, so material flows by gravity. What we see here is the material after it has passed through Bio 1, with the majority of the biogas already extracted, then moving into Bio 2. It looks deflated now because we've left the generators running longer to allow for maintenance. The retention time target is 30 days. How is this calculated? If the daily manure input is 70 cubic meters, the total biodigester volume must be 30 times that amount, about 2,100 cubic meters. Since we planned the project for future expansion, we opted to build 2 digesters. While Bio 2 produces less gas, as 80% of gas is extracted in Bio 1, it plays a key role in system continuity. As we increase herd size, the system will operate closer to peak efficiency. We are already preparing the site for 2 additional biodigesters, Bio 3 and Bio 4. These will be installed in parallel, not in series like the first 2. Incoming material will be split between the 2 new digesters, either routed upward or downward depending on system demand. It may be a bit early to begin Bio 3 and 4, but we needed soil for another earthworks project, so we've initiated site preparation. This space is designated for the 3rd and 4th biodigesters, although we are also considering the option of installing a CSTR, continuously stirred tank reactor, a German standard system with higher gas efficiency, but also a much higher investment cost. For now, we believe the current system offers the best cost-benefit ratio. This is our biogas power generation plant. We have 2 MWM generators, each with a capacity of 130 kilowatts. The optimal operating range is between 70 and 100 kilowatts to avoid excessive wear. Generator 2 powers all climate control systems, including cross-ventilation, fans, lighting, and the scrapers. Generator 1 supplies power to the offices, milking parlor, milk cooling, processing, and the feed mill. The biogas travels from the Biodigester through buried pipelines, entering a gas dryer to remove moisture, then a compressor, and finally the generators. The generators are currently offline for preventive maintenance, including oil changes, spark plugs, ignition coils, and any other necessary components. Generator 2 runs 24 hours per day, requiring an oil change every 250 hours or approximately every 11 days. Generator 1 runs about 6 hours per day. Together, our system now produces 120% of the farm's energy demand, leaving a 20% surplus. This includes 70,000 kilowatt hours per month from the biogas generators and another 40,000 kilowatt hours from solar panels. A truly sustainable and self-sufficient energy model that maximizes on-farm resources.
We are now heading toward our calf housing facilities, where we will show some of the standard procedures carried out by the calf management team. Last night was somewhat atypical, with numerous calvings. Our farm operates 24 hours a day, and we maintain a dedicated calving team that continuously monitors prepartum cows housed in the maternity bay. Once a calving is identified, the calf is promptly brought to the calf barn, and the first intervention, which is naval disinfection, is immediately performed. The process has become increasingly automated. Notifications are sent via messaging groups, ensuring the calf team is informed and prepared. Simultaneously, information about the dam is communicated, so the colostrum is ready by the time she enters the milking parlor, allowing the calf team to assume responsibility for colostrum feeding. For all female calves, whether Holstein or Angus, we aim for a colostrum quality of 22% bricks, administered in a volume equal to 10% of birth weight within the first 2 hours. If the dam does not produce high-quality colostrum, we either reconstitute powdered colostrum to reach the required bricks level, or we thaw frozen colostrum from the colostrum bank for immediate feeding. Esophageal feeding is used only as a last resort. Generally, we rely on patience and calm handling, encouraging the calf to voluntarily consume the 4 liters of colostrum within the initial 2-hour window. Meanwhile, the maternity pen is cleaned, straw is removed, lime is applied, disinfectant is sprayed, and fresh bedding is laid in preparation for the next calving. All new employees or trainees undergo a formal training program conducted by the calf management team. The goal is to ensure precise execution of every procedure, from receiving the newborn to warming, drying, and naval disinfection, and to eliminate any failure during handoffs between teams. We provide continuous training and periodic retraining to ensure process continuity and quality control. Here we have our newborn calves. They are typically born in the cross-ventilated freestall facility and immediately transferred to a receiving pen, where they undergo naval disinfection and colostrum feeding. Afterward, they are placed in individual hutches, where they remain for approximately 30 days. We have 42 hutches, of which 30 are in use, while 10 remain vacant to allow for quarantine and sanitary downtime. During these 30 days, calves receive milk replacer only. No raw milk is used. Initial colostrum feeding follows the protocol of 10% of birth weight within the first 2 hours, followed by an additional 5% at 6 hours post-birth. Afterward, the calves receive 2 feedings of transition milk, then transition fully to a milk replacer. The current milk replacer is mixed at a 13% solids concentration, with a total of 6 liters administered daily. They are also offered commercial calf starter. After the hutch phase, they move to group pens. Due to herd expansion and increased calving rates, we are currently unable to maintain the full 30-day individual housing period. This month, we faced capacity constraints, and until the adjacent expanded hutch area is completed, calves are being moved to group housing around day 20. These are the challenges of growth. At present, we are bottle feeding approximately 60 calves. They remain on milk until around 60 days of age, followed by a 10-day weaning transition, during which they shift to a fiber-based diet.
Our average calving rate is 2 births per day. You may notice some Angus calves among the group. This was part of a strategy implemented 2 years ago to temporarily slow herd growth. We used sexed semen for the first artificial insemination, followed by Angus semen on subsequent breedings. As a result, some calves are black-coated. However, with the current herd expansion strategy, we have discontinued the use of Angus semen and are now working exclusively with Holstein genetics, aiming to increase the number of lactating cows. We sell these calves based on category and age, with prices ranging from 400 to 500 Rs depending on development. Even Angus crossbred calves receive the same high standard treatment as Holstein heifers, particularly during the pre-weaning phase, which reflects in their performance. It may sound surprising, but we have steers reaching 22 arrobas by 12 months of age, which is a direct outcome of intensive care during the early stages of life.
In general, Holstein heifers show consistent growth rates, but once they enter the post-weaning group pens, their performance accelerates. When housed alongside Holsteins, the weight gain of Angus cross steers is impressive. Our goal in the group housing phase is to promote social adaptation, rumen development, and immune strengthening. We typically house 8 calves per pen, offering them a total mixed ration, TMR, as well as the same commercial calf starter previously provided in the hutches. They progress through several stages until weaning is completed. This month, we also began using health monitoring ear tags, which provide real-time alerts whenever a calf shows behavioral changes or drops in activity, enabling early intervention. This technology allows us to respond to signs of dehydration, pneumonia, or other issues before significant developmental loss occurs. As I mentioned earlier, you may see male calves in the pens. These are Angus crosses, and they receive the same management protocol as the Holstein heifers. Many are already entering the pre-weaning transition phase. At this stage, calves are already on a solid diet, supplemented with small amounts of long fiber to support rumen development. The health monitoring system flags any calf that deviates from expected feeding or movement patterns. If a calf spends more time lying down, the system generates a health report, triggering pre-diagnostic evaluation. This helps us identify and treat conditions such as dehydration or respiratory disease before they compromise growth. The ear tag is applied on the 5th day of life, and it takes about 5 to 7 days to learn the calf's routine. By day 10, the system establishes baseline behavior patterns and begins generating alerts for any abnormalities. Here, we have weaned calves, now housed in pens with approximately 16 animals per group due to our current stocking density. Here, the heifers are being prepared to move to another compost barn, where they will remain until they reach the breeding phase. They are already receiving the same diet as they were in the previous pen. We have 2 pens with around 20 animals each, serving as transitional groups. Animals typically stay in these pens for about 120 days. The leftover feed visible here is from the previous day. A new feed delivery will take place around 10 a.m. The diet provided here is essentially the same as that fed to lactating cows, consisting of corn silage, ground corn, soybean hulls, cottonseed, mineral premix, and soybean meal. Since we are still building our new feed center, we have temporarily limited the number of ingredients in the ration mixer as we await completion of new ingredient bins. Currently, we prioritize corn and soybean meal, alternating between soybean hulls and citrus pulp, depending on the quality of the corn silage. About a year ago, we had to start incorporating cottonseed, which previously was not part of our diet due to operational limitations. This farm takes pride in maintaining simple yet well-executed processes. The focus is on operational clarity for our team, simplifying execution while maintaining high standards. One differentiating factor here is that even yesterday's leftover feed has no off-odor, and the silage is exceptionally well preserved. Since we work with a 100% silage-based forage system, our ensiling process is taken very seriously. especially compaction and proper inoculant application, to avoid losses and ensure high dry matter intake. After weaning, calves are transferred to this barn, starting with 2 20-animal pens. We avoid high stocking density during this transition phase, particularly to ease their adaptation to headlocks, minimizing the risk of injury. During this phase, the calf management team remains responsible for monitoring whether the animals are feeding properly and adapting to the new environment. These calves are the first to be fed each morning. Our workers arrive around 6:50 a.m., begin removing silage, and feeding typically starts around 7 a.m. to 7:10 a.m. These animals receive a custom ration with a slightly higher concentrate level to enhance the energy density of the diet. This strategy prevents overconditioning in later stages when higher energy diets are inappropriate. After leaving this phase around 4 months of age, the heifers move through progressively larger groups, following a gradual growth transition. The progression begins with groups of 20, then moves to 40, and finally up to 80 animals per pen. Before feed is delivered, since the feed bunk score is already low, animals are briefly confined to the bedding area while the feed alley is scraped, currently still done manually with a tractor, unlike the lactating pens that already use scrapers. After the alley is cleaned, the feed is distributed, and animals are released for access. Since the animals are fully confined, and we maintain excellent environmental control, they are not exposed to parasitic pressure such as ticks and receive consistent feed intake. However, despite our high reproductive efficiency, we occasionally observe overconditioning in heifers aged 13 to 14 months. This excessive weight can negatively affect reproductive performance, and in severe cases, lead to complications such as ketosis during calving, or even mortality. To avoid such losses, we adopt a preventive nutritional strategy, focusing on controlled energy intake. Losing a heifer at the moment she begins to provide economic return is a major setback. For the dry herd, except those in prepartum, we use 2 types of forages throughout the year. One of them is sorghum silage, particularly giant sorghum, which has low energy content and higher neutral detergent fiber, NDF, reducing dry matter intake by up to 2 kilograms per day. The other source comes from a local supply chain of green corn, widely sold in coastal and metropolitan markets. We purchase the harvested corn plants, post-ear removal, from neighboring farms and N-sile, the vegetative fraction, specifically for the heifer grower phase. The challenge with post-harvest corn forage is that even with only 10% of ears remaining, it still contains residual energy and has lower NDF content. This can lead to excessive weight gain in breeding groups, especially if feed is not restricted. Sometimes we allow animals to run out of feed by 6 to 7 p.m. to avoid overconditioning. This particular pen houses 74 animals. Their average dry matter intake is approximately 6 kilograms per day. Their base ration includes corn plant silage, without the ear, with 28% dry matter. To this, we add 1.1 kilograms of soybean meal and around 120 grams of mineral premix per head. Feed intake varies by group. Breeding groups consume up to 7.5 kilograms of dry matter. Transition heifers consume around 6 kilograms. Newly moved animals consume approximately 2.5 kilograms. As I've mentioned, the farm's guiding principle is to simplify processes while ensuring precision and effectiveness. Instead of focusing on the number of feedings, we prioritize that each feeding is executed properly, that the feed is pushed up, kept fresh, and consumption is monitored to avoid performance losses. Since the farm owns its own self-propelled forage harvester, we currently chop corn silage at 11 millimeters. We are still evaluating whether to reduce particle size to improve compaction and fermentation. However, doing so may increase rate of passage and dry matter intake, which we do not desire at the moment, as current consumption levels are satisfactory. Still, owning our own equipment allows us to experiment, monitor, and potentially fine-tune this aspect of feed preparation in the future. This is our rearing pen 6, where we house the breeding age heifers. All teams focus their attention here: feed management, bedding, and especially reproduction monitoring. We do not use heat detection collars, so heat detection is carried out entirely by trained staff. The team operates via messaging groups, where any team member passing by can report an animal in estrus, sharing her identification number. The reproduction team then verifies whether the heifer was mounting or standing to be mounted, confirms signs of estrus, and makes decisions on whether or not to inseminate. We emphasize body condition scoring in this phase. Obesity is undesirable, except in specific cases such as Angus females, which tend to gain weight more easily due to their genetics. These Angus females are now often used as recipients for embryo transfer. These heifers are reaching breeding age, and we aim for first service around 13 months, targeting first calving at 24 months. Last year, through proper planning, we reduced that to 23 months. It's worth highlighting, especially for nutritionists watching this video, that each case is unique. The diet we use for this category may cause weight loss on other farms, but for us, restriction is necessary to prevent overconditioning. Daily visual monitoring of animal groups is critical. Numbers and data are useful, but by the time performance metrics show an issue, it may be too late. So we assess the animal's physical condition, response to dietary changes, and muscle development on a daily basis to prevent performance losses in the future. This hands-on approach is key. Currently, our rearing pens are slightly overstocked, operating at about 20% above headlock capacity. We are building a new rearing barn that should be operational in about 1 month, which will help relieve current stocking pressure, though temporarily. The new space will follow the freestall model, preparing animals for the adult confinement system. Since we use cross-ventilation, we place strong emphasis on cleaning cooling pads and pipes, especially during summer. Weekly pipe sanitation is standard, and cooling pads are inspected monthly, more frequently if excessive dust or organic matter accumulates. We never go more than 30 days without cleaning or checking them.
Speaking now about our forage production, our own land is quite limited. Only 50 hectares of cultivable area at headquarters. Back in 2018, that was enough to feed our smaller herd of 200 lactating cows. For many years, we followed a double cropping system, planting both main and second season silage on these same 50 hectares. However, to support increased milk production, we began leasing additional nearby land, which improved feed security and forage inventory. Today, we lease 310 additional hectares, primarily for corn and some soybean as part of our crop rotation strategy. All leased fields are close to the farm, simplifying silage logistics. Even so, we rely on a fleet of over 14 trucks to bring all forage to the on-farm silage bunkers. With more land, we now focus exclusively on main season whole plant corn silage for lactating cows. We've gradually increased the cutting height to about 40 to 50 centimeters, aiming to boost starch content. We do not use fermented grain, high moisture corn, snaplage, or reconstituted grain. Instead, we aim to concentrate starch directly through cutting height adjustment during ensiling. In our context, cutting too low reduces starch and would force us to harvest separate dry grain, which adds costs, losses during harvesting, drying, and milling. We used high moisture corn for a while, but compaction and kernel processing remained challenges. We've used snaplage successfully when needed, especially in second crop harvests, to increase dietary starch. But now with robust main season silage stocks, we rely solely on dry corn grids. We apply heavy fertilization rates such as 250 kilograms per hectare of MAP, monoammonium phosphate, 250 kilograms per hectare of potassium chloride, 450 to 480 kilograms per hectare of urea. This has significantly improved forage quality. We previously used soil fertility mapping with 1 sample per hectare and variable rate fertilization, which brought great results. Today, with more stable soil profiles, we're transitioning to fixed rates, except for potassium chloride, which is still applied at variable rates. We typically plant corn between early and mid-September. All whole plant corn silage is produced in-house, allowing cost control, fungicide application, and quality assurance. We had contracted silage services for 12 years, But frequent issues, especially harvest timing, led us to purchase our own self-propelled forage harvester. This was a turning point. Now, we harvest corn at optimal dry matter, between 34 to 37%, ensuring excellent silage. We avoid harvesting during rain or poor conditions, which previously led to soil compaction. The machine has been essential for forage quality, especially in kernel processing. We maintain the equipment in excellent condition, even replacing the kernel processor before breakdowns occur. Aside from whole plant corn silage, we also use a lot of vegetative corn silage from fields harvested for green corn. In our region, many producers sell corn ears, leaving behind the stalks, which we purchase and ensile. This turns a logistical problem into a valuable forage source, especially for the growing heifers. This material is cheaper than producing our own. It's available year-round, allowing us to maintain a robust inventory. Right now in May, we already have enough supply until September of next year. This gives us flexibility to select fields, harvest closer, or negotiate better prices, reducing forage costs. In this crop year, we harvested around 8,500 metric tons of whole plant corn silage. We purposely increased inventory, and our current supply should last until May of next year. We harvest in January so the silage will ferment for 4 more months, improving starch availability and overall dietary consistency. Although it ties up capital, this strategy gives us security and quality. We are already purchasing fertilizers in mid-2025 for January 2026 harvest, with usage projected until May 2027. Although this strategy immobilizes significant capital, it provides uniform forage, enhancing herd performance. We use few hybrids, all with similar cycles, so bromatological variation between silos is minimal. We previously saw milk production drop by 3 to 4 liters per cow per day due to abrupt changes in silage quality. With this new strategy, cows experience fewer dietary shocks, and starch availability improves through longer fermentation. From this year's main season harvest, we produced 8,500 metric tons. And since December, we've also ensiled around 5,000 metric tons of vegetative corn silage. This inventory gives us freedom to rotate some areas with soybeans. During the second crop, we focus on grain corn, leaving residue in the field to improve soil structure and microporosity. This year, we also began a new soil management strategy, focusing on compaction reduction. For the first time, we are using a subsoiler with 40 centimeter tine depth and 60 centimeter spacing. The goal is not only to address compaction, but to increase rainwater infiltration. The cheapest irrigation is storing rain in the soil. Though not perfect for decompaction, this practice helps in drought resistance. Given our sloped terrain, we even eliminated some contour terraces, relying on increased infiltration capacity to prevent erosion. We are now inside the packaging room of Laticinios Mamma Mia, where we bottle our own milk under our own brand. Our milk is distributed to nearby towns, especially Pilar do Sul and São Miguel. This brings our high-quality milk directly to local families, who know and trust our work. Here is our cold room, where milk is stored overnight for next-day delivery. Thanks to a municipal partnership, many local children are drinking this pasteurized, homogenized whole milk, free of preservatives and ultra-fresh. Our milking parlor is located less than 20 meters from the packaging room. Within minutes, milk is collected, pasteurized, homogenized, and bottled. We take great pride in offering such quality milk to our own community, especially its children.
I want to emphasize that none of this would be possible without our team. The results and growth of this farm are thanks to our dedicated collaborators who give their all, even when facing daily challenges. I'll name a few supervisors who represent our entire workforce. Marcos, our most senior employee, here for 23 years, leading reproductive management, the heart of the farm. His sons, and Vinicius, head of milking operations. Rodrigo, responsible for environmental control and nutrition. Ferdinando, who manages the calf barn. These leaders and their teams are the foundation of everything we achieve. The Mazer de Carvalho family provides opportunities for other families, many of whom now have generations working here. Some of their children are studying veterinary medicine, planning to carry forward the work their parents began. That continuity is what truly makes us proud.